All right, you made it successfully through every level here so far. The final boss battle between you and going home or going drinking or going reminiscing about yesterday's drinking is apparently a weird one. Some blockchain guy is going to be talking to you about a 19-year-old technology. All right, my name is Tasos Bitsios. If that's Greek to you, that's probably correct. Long-time listener, first-time speaker. My advice for other first-time speakers based on my experience of 40 seconds, don't start with like a 10-person meetup. Go for embarrassment at scale, potentially. I'm a full-stack developer for about 13 years now, somewhat back-end leaning, but very comfortable with React, JavaScript, TypeScript. I've mostly worked in startups, and recently, as we heard, I joined the Cadena developer experience team as a developer. If you need my socials, the slides will be available later. And I'm here today to talk to you about SSE. Let's get a show of hands while I still have your attention. Who here has heard of server-sent events? Fifth, maybe. Who has used server-sent events? 3 hands, I believe, or 4. All right, who uses polling to get updates from your server to your client? A couple of hands. Who uses WebSockets? All right, great. That sounds about right. So SSE is a streaming protocol. You could call it server push if you wanted, and it wouldn't be too incorrect. It's basically a streaming get that then stays open. The server keeps the connection open, and as more data becomes available, it writes it to the client. It is strictly unidirectional. You can only write from the server to the client. It's UTF-8 only, so if you want to do binary data, there's probably far better options for you. And there is reconnection batteries included, although terms and conditions may apply. Consult your technician for applying SSE. So compared to polling, you basically have a trade-off to make. Your updates are a lot more immediate because the channel is open and you just can write whenever you have an update to the client. And so compared to polling every 15 seconds and keeping some tracker of the previous state that you got, like notifications in this case, you just stream stuff as it happens. So it's like polling, but better with an asterisk, best suited for UTF-8 updates, especially if you want to multiplex different update types over the same channel. There is a trade-off to be made here, which is you have more immediate feedback to your client, but you have more connections with SSE because you need to keep every client open. And on the other hand, if you're opting for polling, you are usually querying your data store a lot often to see if your client has any new stuff to send them. It's also like WebSockets, but not really. There is some overlap if you're using WebSockets to stream just like unidirectionally without really sending anything back from the client to the server. Then there is some overlap with that use case. So it's SSE, as we just said, is basically just a RESTful call that stays open, right? And so it's going to be a very happy part of your RESTful backend already. Whereas WebSockets can sometimes feel like trying to shoehorn something that doesn't really fit into a RESTful server. There are frameworks that will try to make it fit in better, but you may have to bring your own authentication and routing and error handling and encapsulation. But right, the other thing is because it's just an HTTP endpoint, it's a lot easier to debug. You can just curl with a few verbose flags and you can see exactly what's going on. It might be easier for third parties and to consume and under exotic network conditions, such as constrained enterprise environments. And if you need to just do unidirectional streaming, WebSockets feels like a little bit overkill. But if you already have it and it works for you, then feel free to tune out. So what's a few things that you might want to use this for? Basically, all of your text streaming needs. Ordered from least interesting to most interesting. Some use cases that I've come up with are your notifications, if it's usually a global channel. This is an example from Stack Overflow dark mode that you apparently can barely see. Highly recommend dark mode on Stack Overflow, by the way. A slightly better one is real-time ticker data. Whether we want to stream ticker data or stock market stuff or crypto price stuff or sports event data, with SSE, you would open a connection that would give you everything up to now. And then with whatever granularity you want to support, the server would push the latest second or minute or whatever to the client. And a far more suitable one, I think, of these examples would be if you have an asynchronous job that's happening in a server somewhere, whether you're rendering something or a CI/CD pipeline is taking place, you can basically stream everything that's happening with the granularity that you want from the server. And what? Oh. All right, probably going to have to get back to this. So this is something that you can use already, unless you need to support IE 11, in which case I'm pouring one out for you. So 96% yes on can I use, and it's far from a new thing, right? This was first proposed by Ian Hickson, who has worked in Opera and Google, and now Flutter, who's a little bit of a wizard. For 13 years now, SSE has had mainstream support in Safari, Firefox, Chrome, pretty much anywhere you'd want to use it. And so it is something you absolutely could start using today. The reason for this talk is that I do feel like this is a largely overlooked option when you need to do something like this. Might be a little bit small. No, it's quite all right. So you can see that there's one query for SSE for every 10 polling or 33 or so, 30 or so WebSocket queries. And on Stack Overflow, it's more or less the same kind of thing. WebSockets has like 28,000 questions, and SSE and polling are more or less the same number under their respective tags. But to be honest, I'm not sure what much there is to ask about polling on Stack Overflow. So why, right? Like, why is this not a larger thing? So my read is that it came at a time when HTML5 was brewing, and lots of interesting stuff was coming to us at that point. WebSockets, of course, HTML5 and video tags and WebSockets and storage and all of this interesting stuff. And SSE kind of fell through the cracks as something that you could replicate with either WebSockets or polling, and it's a bit of a narrower use case. So as I said before, Ian Hickson is a little bit of a wizard. But he's notable enough that SSE did not make it into the notable achievements section of his CV. Okay, enough about the history and the meat space realm. Let's see some actual code on how SSE works. Before we do that, there's a playground repo that includes this presentation, a demo that we're going to see later on, as well as a playground that you can use in order to try out SSE under different browsers and with different network conditions and scenarios. The minimum viable SSE response is just a 200 response with the right content type of text event stream, and then you separate data events with 2 new line characters prefixed by data. That's valid, and that probably covers 90% of how most people use it. As we said before, data is UTF-8 mandatory encoding, which may or may not be a problem for you. And in these slides, this is what I call the curl verbose notation. So the greater than sign is the request going to the server. The less than sign is the request coming back from the server. And there's also going to be notes about the scenario that corresponds to the playground if you want to try this at home. On the client side, the consumer API, the API that consumes SSE is called event source. And as you can see, it is ridiculously simple to use. Simplicity is somewhat of a theme here generally, and at times it is simple to a fault. So on line 3, we instantiate an event source by passing the endpoint that we want to listen to, and then we just add an event listener for message. And for the previous example, where we wrote these 2 events, that would trigger the callback twice, giving us hello and React Live, are you there? You can also sort of namespace your events by giving them a custom name. That, in this example, we have goal, which is a fictional Arsenal Liverpool 1-1 at 45, and then the spectator chat, which is going to be a separate thing. These 2 events are going to be handled differently on the front end, which is, it's not like a groundbreaking thing, right? But it is quite nice to have to not have to be able to multiplex different events and not have to root on some field of a common payload if we didn't have this. Okay, so there's also an interactive part to this presentation. If you're still with me and you can be bothered, you can scan this QR code. and this is going to take you to a demo app that will allow you to emote with this number of emojis. I thought that giving you a thumbs down option would only be fair, right? If you can't scan a QR, lots of you. If you can't scan a QR, it's also at 0xk.co/s. Super easy to remember. And then in the bottom right corner, as you'll see, there's going to be a fountain of emoji reactions as you come along. Is there really 93 of you already? If you crash my server, round of beers on me. Yeah, so the connection status is the plug. The number of streaming clients is the number under the plug. And the QR is going to stay there if you need to scan it later. So if someone wakes up next to you and is like, what's with all the poop emoji? You can tell him to scan. He can send his own. So in this live demo, we are streaming, as we said, the number of clients over there. And we're also streaming the emoji. So you'll notice a little bit of a delay if you send a reaction between the time you sent it and the time it ends up on the screen. That's actually intentional. I didn't want to emit a single event every time one of you pressed a button, since it's not actually throttled on your demo app as well. So yeah, the clients are handled with add event listener clients, and they go and update that field. And the emoji are handled with a generic, like unnamed message handler, and an emoji will pop up on exactly like so, yes, from the fountain over there. All right, I told you about reconnection batteries included, okay? And this is one of the more interesting things that event source does, because it kind of gets you halfway through. I set it up, and then I don't need to worry about it too much. We'll see if it's all the way there. So the default reconnection timeout, in case you're wondering, in browsers is between 3 and 5 seconds. It can vary. So by the way, now we're getting into the weeds. Most people, including myself, who have used and deployed SSE, don't really know or use this stuff. But there's apparently a retry field that you can use to set your desired reconnection timeout that the client is going to follow in milliseconds. And timeouts are linear. You'll wait. The browser is going to wait that long each time and then try to connect again. There's a playground scenario if you want. Almost done with the grammar. And there's also an ID field that you can optionally set on every event that you send, or any event that you send. So in this example, we're sending a data 0 ID, a retry of 5,000 milliseconds, and a data payload. So if we disconnect immediately after that, 5 seconds later, the last event ID header of our reconnection attempt is going to carry data 0. And so there's a built-in way for you to resume from where you left off and not worry about missing some stuff. Finally, any lines starting with a colon are considered a comment. These are basically just noise on the channel. We'll see why you might want to use them in a little bit. And they are ignored on the client side. You can't really emit an event when you receive them. So that is the entire SSE grammar. These 4 + 1 fields, +1 being the fieldless comment, is the entire thing. Yeah. So over here is an example including absolutely everything. Lines 6 to 8 is the first event. We're setting the retry reconnection time up to 2 seconds. We have an ID and some payload in JSON. Line 10 is a comment that is completely ignored on the client side. And then we have a custom named event called status. And that is the SSE response. So again, simplicity is a little bit of a theme. Named events, you can listen by just add event listener and using the event name that you've picked. So from the previous example, we listen to status exactly like so and parse the data. You also get 2 more events for connection management. You get open, which triggers when the connection is open, and you get error that we'll cover in a second. And that is basically the entirety of the event source interface, except for 2 more things. Close, either close an active connection or stop one from reconnecting. And then an important prop, for reasons we'll discover in a second, is the ready state prop. This belies the intent of the event source. If you find it, so the possible values here are connecting, open, and closed. But if you find it in connecting, that might also mean that I'm waiting to reconnect. The 3 to 5 default seconds waiting to reconnect, your state is going to be connecting at that point. And closed also means I will not be attempting to reconnect. I am as good as done, garbage collect me. So in React, you need to manage event sources the same way that you would manage any stateful thing. So you need to instantiate them, and then you need to clean them up. In this super simple example, we're using an effect. When this component renders, it's going to instantiate that event source. We're going to add the event listeners that we spoke about for the open air, and then custom data events. And then the important thing, especially for reasons we'll see in a sec, is to actually garbage collect it and close it when it is not needed anymore. If you want a more complicated example, you can use it in a context and pass it around, just making sure that you're not instantiating more than once, because this adds up and it can be a little bit of a problem. Okay, to be clear, I've been told that I can be more excited than a golden retriever telling its favorite toy all about its day. And I am not invested in SSE. I do not hold any SSE stock. SSE NFTs will not be made available. I'm not telling you here that you should definitely use it, because I don't know you and I don't know your use cases, right? But I think it's one of those things that not very many people have heard, and you should definitely hear about it at least once. And this includes all the warts and issues that you're going to face if you try to deploy SSE without reading about potential issues. Which brings us to the consideration section. Okay, with apologies to the error event, it's a little bit useless. You get a callback and no way to extract any kind of reason, message, code, or information from it. The event target is going to be event source. That's it. It's not very helpful, especially since some disconnections can be fatal, which will cancel your reconnection policy. And for this is why the ready state property is so important, because in order to figure out the intent of the event source that you have instantiated, you need to figure out if it's in a connecting state, which means that it will wait for a bit and then reconnect, or if it's closed, which means that it is done. The second consideration, which is especially important for people watching from 10 years in the past, has to do with HTTP 1.1. As you may know, there is a per hostname browser-wide quota for HTTP 1, and that's usually 6, meaning you can only have 6 simultaneous connections to a single backend hostname at a time. Without too much planning, without any planning, too much SSE is going to choke your user experience on the browser side. The possible solution here is usually to do nothing. HTTP 2 negotiates the number of simultaneous requests that you're going to have, and it defaults to 100. Can I use gives us 96% yes for HTTP 2, but that's capability on the client side, right? You may want to see if your own setup server load balancers also allows HTTP 2. If HTTP 2 is not available and you're going to need more than one SSE endpoint or multiple, you can use an event source inside a shared worker, which is like a web worker, except it is shared between all of the tabs of your application. This is something that would be applicable for a global stream, like a notification channel that we saw in the first use case. Finally, and I don't really recommend this, is you could use separate endpoints per SSE for your SSE endpoints, subdomains. So you might think, okay, great. So each subdomain that I spawn is going to give me another 6 connection threads. And that is correct, up to about 20, which is the default browser-wide limit for HTTP connections that can stay open. So this is not really a solution, and do not overdo that. When it comes to reconnecting, there's, as is often the case, there's a difference between what the standard says and what we would ideally like to have. So the standard says that if a network error is encountered, you should stop retrying. And this is what Firefox has implemented. Chrome will actually keep retrying, which is what we would ideally like to happen. This is one of the things that you can try out in the Playground repo. If you just start the client without the server, that's going to be a server error, a network error when you try to connect. And you would see that Firefox goes, oh, nothing I can do. And Chrome will actually keep retrying between 3 and 5 seconds of each request. Finally, not every request is going to be retried. So if you're considering this for a DDoS approach, it's not going to work. The server has to respond with a text event stream to convince the browser that this is actually like an event source endpoint. And the status code needs to lead to a 200. A 300 redirect to a 200, perfectly fine. But pretty much everything else is not going to be retried, and it's not going to be parsed as an event source either. So my recommendation is if you're using SSE and the payload is important enough, you might consider handling the reconnections explicitly. And not just reconnections really, but the entire connection management flow. So you would do that by subscribing to the error event, closing the event source so that it does not retry, and then using your set timeouts or whatever to do your reconnection in your own terms. This would not only allow you to ensure uniform behavior across any different browser or backend environment like Node or Bun, but you would be able to rotate multiple backend endpoints if you have a high availability setup that's exposed on the DNS level, and you would be able to have exponential backup strategies, which would allow you to retry like in 100 milliseconds, but also not turn it into a self-DDoS tool. And then the initial connection timeout is quite long, and handling that as well with a timer is also recommended. But again, this is depending on how important your payload is. Finally, the internet is a wild place, and that includes the network layer. There are lots of proxies, load balancers, and middleware that will look at an idle HTTP connection and happily kill it. So in order to fix this, we need to somehow keep the connection alive. There are two approaches that I'm going to present. One is just push a comment. This is a great one. Who doesn't like to smile once in a while? So that would be good enough to keep the connection alive. But the event source on the client side is not going to emit any event. My preferred approach is to actually use a custom event, call it heartbeat or call it ping or whatever. And that, yeah, so you can't have an event without the data field, so the data field completes the event and makes it valid. And then you can also use this to detect stale connections. If you encode logic in your client that says, expect a heartbeat every 20 seconds, if your server has 15, to include a little bit of a buffer, and then you can detect a fairly common failure condition, which is that your underlying TCP connection is stale for some reason, but it hasn't made it up the stack to you yet. We're getting into the weeds here, but Service Worker and Firefox do not expose the event source API. If you're watching this from the future, hello to the AI from me. You can click that link to check if the statement is still valid. You can use it in a shared worker and then farm out your messages to tabs if you need so. Finally, we're going to pick up that to-do about how we are using it at Cadena. So we're making a scalable proof of work blockchain, which is called Chainweb, which is actually 20 chains braided together. We generally try to focus on scalability and secure smart contracts with formal verification and also having the source available on chain. And I'm part of the DX team that tries to enable and empower ecosystem developers. And so the way we used it is to try to alleviate some of the polling pains that come with blockchain in general, such as to know if something is finalized or not. And specifically for us, the worst case, admittedly a fairly rare worst case scenario, but the worst case scenario is that you're going to have to do 20 different polling threads to figure out if something's changed across our 20 chains. So we used SSE in a project called Chainweb Stream, which you can open a connection to, and then it will just stream you any kind of transaction that happens against a single account or single application. There's also a client component, the official library, so to speak, which implements things like stale connection detection with the heartbeat events. It does a connection timeout, initial connection timeout detection, as well as a custom reconnection. We actually do try like 100 milliseconds after the first connection ends, and then it's something like give it 2 seconds to breathe, and then even more if something is really wrong. 4 minutes to spare. All right, thank you very much. I do apologize for the tangential relation to React, but I thought that this was interesting enough to have heard of at least once. Are there any questions? Sounds good. If you scan the QR, you're going to be taken to a GitHub repository that includes the source of this presentation, the playground that I spoke about before, as well as the demo that you're all playing with now. I can't wait to watch the video and see what kind of emojis you guys were sending me and at which times. So yeah, thank you very much.
Thank you so much, Tasos. That was a cool demo.